Hi everybody, Mrs. Bolin here, and we're going to take a look at Learning Target 5.3. I can solve systems of equations by elimination. And we have previously looked at solving systems of equations by graphing and by substitution, but now we're taking a look at a third method called elimination. So our first step is going to be to add the equations vertically, which may sound funny, but we're going to add the equations vertically so that one of our variables, so one variable gets canceled or eliminated. One variable gets canceled or eliminated. And notice in example 1, our equations are in a certain form. In order to use elimination, they have to be in this form. This is called standard form, where you have your x term, then your y term, equal to your constant term. So if it's in standard form, then you'll be able to add these equations vertically, so one variable gets canceled or eliminated. Once we do that, we'll have half of our answer, but we'll have to plug the answer back into one of the original equations. So we can say plug answer back into one of the original equations. And I'll make a note for us, this is a reminder, that when we're solving systems of equations, our solution is an ordered pair. So this is a reminder, solution is an ordered pair. Solution is an ordered pair. So our directions say to solve each system by elimination. And in example 1, my two equations are in standard form. And so what I can do is I can turn this into one big addition problem, meaning I will add the x terms, I will add the y terms, and I will add the constant terms. So again, I'm adding these two equations vertically or up and down. So I'm doing 8x plus a negative 8x. So I'm saying, what's 8x minus 8x? Well, that's just 0. That cancels. So my x's just canceled or got eliminated, which is what we want to happen. We want one of our variables to drop out of the problem. Now let's add our y terms. Negative 9y plus 7y gives us negative 2y equal to, and now I need to add my constant terms. So negative 21 plus 11 gives me a negative 10. So notice we no longer have an x term because our x's got eliminated. They dropped out of the problem. So now I'm trying to solve for y. This is negative 2 times y. So to undo that, I need to divide by negative 2 on both sides. And I'll get that y equals negative 10 divided by negative 2 gives me a positive 5. So now I know half of my answer, but I need to plug y equals 5 back into one of the original equations in order to find the x value, because again, my solution will be x comma y, an ordered pair. And this is familiar because we always had to plug an answer back in so that we could find the other half of our answer to write it as an ordered pair. We did that with substitution. So you can pick either of these equations. It doesn't matter. I'll just use the first equation. So my first equation here, I'm going to write 8x minus 9y equals negative 21. But instead of writing the y, I'll put parentheses because I'll plug in what y equals. So I have 8x minus 9 parentheses equals negative 21. Notice I did not write the y in my first equation because I'm plugging in that y is 5. And then I can simplify here. Negative 9 times 5 gives me negative 45. Trying to solve for x here, so I can add 45 to both sides. And I'll get 8x equals negative 21 plus 45 gives me 24. My last step here would be to undo 8 times x. So I would need to divide by 8 on both sides, and I get that x is 3. So for my final answer, I do need to write it as an ordered pair. x comma y. So my final answer will be 3 comma 5. And this is the point that is the solution to these two equations, meaning I can plug in x equals 3 and y equals 5, and it will satisfy these equations, or it will make both of them true. This is also the point of intersection if you think back to graphing. Let's try one more example. So example 2, I can create one big addition problem here, and I'm adding vertically. So negative 6x plus 6x. Looks like my x's are canceling again. So x's got eliminated from the problem. Negative 7y minus 2y gives me negative 9y. 3 plus 24 gives me 27. Trying to get y by itself. To undo this negative 9 being multiplied by it, I can divide by negative 9 on both sides. And I get y equals negative 3. So here's half of my answer, but now I need to plug this negative 3 back into one of my original equations. It doesn't matter which of the original equations you pick. I'll just pick the first one again. So I'll write my first equation exactly as I see it, but instead of writing my variable y, I'll put parentheses because I'm going to plug in what we just found y to be. So I have negative 6x minus 7 times y equals 3. I know what y is. We found y to be negative 3, so I can plug that in. So I have negative 6x, negative 7 times negative 3 turns to a positive 21. Now I can subtract 21 from both sides, and I'll have negative 6x equals 3 minus 21 gives me negative 18. My last step here would be to divide by negative 6 on both sides, and I get that x equals 3. So now I know both my x and my y value, and I can write it as an ordered pair, 3 comma negative 3. So my solution to the system of equations in example 2 is 3 comma negative 3. All right, so at this time, you have two U tries. Go ahead, pause the video and see what you come up with. Let's see how you did. In the first U try, my x's ended up dropping out of the problem. This may not always be the case. Sometimes my y's may drop out, but my x's dropped out of the problem and I got y equals negative 3. I plugged y equals negative 3 back into my first equation for y, and I ended up getting that x equals 1. So my solution was 1 comma negative 3. On the second U try, something interesting happened. My x's canceled, my y's canceled, so I was left with nothing on the left side, or you could write a 0 as a placeholder. And on the right side, I was left with negative 5. Does 0 equal negative 5? No, I'd put a slash through it. That cannot happen, that's false. 0 will never equal negative 5. Or this is familiar, this happened with substitution. When you get a number that is not equal to another number, we get no solution. There's no solution to this system of equations. No solution. I'd like you to also make a note, because there was another special case that we learned besides no solution. So let's add a little note here that when we get that a number is equal to a number, and maybe you already remember that, let's say if here we had negative 5 equals negative 5, or a number that is equal to a number, then there are infinite solutions. So we'll say there are infinite solutions. So again, those are our two special cases that you have to remember. We saw these when we were graphing, and we also saw these with substitution. But if you get a number not equal to a number, there are no solutions. And if you get a number that is equal to a number, there are infinite solutions.